Okay, so let's now take a look at this geometry problem which appears in this year 2025 British Mathematical Olympiad round 2, and it is put in the second problem. Okay, so personally I think this problem is not that difficult, but you have to prove it step by step. So you can finish the proof after several steps. Okay, so let's first look at this problem. We can know that P and Q, these 2 points are located on the angular bisector of, no, not angular bisector, perpendicular bisector of the segment BC, right? And I is in center. X is the intersection of the two circles, and D is the intersection of AX and BC. So I have to prove that point D lies on circle APQ. So how can we solve this problem? First, what is X? X, it is the intersection of the two circles. It is so abstract for us to understand, right? So we have to make it more precisely, make the location of X more precisely. So how can we do that? We just guess. If you use the ruler and the compass to draw this diagram, you will find that, and you can make a guess. You can just think maybe X lies on the perpendicular bisector of VC, which means PQ and X are collinear, right? And also, according to the diagram, or actually you might not find that, but it is true. X lies on the angular bisector of the angle BAC. Yeah, so we have to prove that X lies on the perpendicular bisector of VC and also lies on the angular bisector of angle BAC. So we prove that, like, we have step 1. PQ and I are, no, not I, X are collinear. So if we have to prove that the two angles are collinear, no, the 3 points are collinear, what methods can we use? You can first think of, yes, to prove that the angle A block Q equals to A block P. So here we can use X, right? So we will start from here. Okay, so what is IXP? IXQ, we start from this. What is the angle IXQ exactly? It equals to IBQ, right? What is IBQ? It equals to angle IBC minus angle QBC. So what is angle IBC? It is half of angle B, right? We just use BAC to stand for the 3 large angles of this triangle ABC, okay? So what is QBC exactly? It is QCD, right? QCB. Because of the, like, B and C are symmetric to this line PQ. So angle QBC equals to angle ICB equals half of angle B minus half of angle C. Furthermore, okay, we have angle IXP it equals to angle ICP, right? Here we have to connect the points P and C. So what is ICP? It is angle ACI minus angle ACP. Or there is another understanding of this angle. What is P? What is the point P? It is on the perpendicular bisector of BC. So we can also connect PI so that ICP equals to angle PBQ. What is PBQ? It is angle IBQ, right? So we don't even have to use these parts. According to the symmetry, so we can get angle IXP equals angle IXQ. So we can just erase this part. It's not required anymore. So we just move it to here. So then we can make a conclusion. P, Q, X are collinear. So this means X lies on the perpendicular bisector of BC. Then we have to show that X lies on AI, the line AI. So it means that AIX are collinear, right? So this is step 2. AIX are collinear. What kind of methods can we use? Alright. So here, what is we can use like okay, what is angle? We can try to prove this equation. Angle AIB plus angle BIX equals to 180 degrees. So that we can prove that. So what is angle AIB? It is 180 degrees minus half of angle A minus half of angle B. Then plus, what is angle BIX? Angle BIX equals to angle BQX equals to 90 degrees minus angle QBC, and then equals to 90 degrees minus QCB, and it is half of angle C. So okay, we have this equation. So we have angle AIB plus angle BIX equals to 270 degrees minus half of angle A plus angle B plus angle C. What is this exactly? 180 degrees, right? 180 degrees, half of it is 90 degrees, and then we use like 270 degrees minus 90 degrees. It is 180 degrees. So AIX are collinear, right? It does not look so difficult, right? up to now, right? So after these two discovery, or after these two steps, what's next? From now we can know what is point D. Point D is the intersection of the angular bisector of angle BAC and BC, right? So then next, for me, I have found one thing, which is A, B, X, and C are concyclic. Let me use another graph. Okay. So we now have step 3. Step 3. A, B, X, C, concyclic. How can I claim this? Have you ever seen one model like in a circle? No, a circle with a triangle inside, and then its angular bisector here. It is the intersection with the circle, and it is the excenter, not excenter, the center of the circle. So here, these two segments are perpendicular to each other. So is this model similar to the problem? That's what we have to discover. Can you discover that? That's the most important. So we know that here we have PX perpendicular to BC, and then we have AX is the AX bisects angle BAC. So can we prove that A, B, X, and C are concyclic? The answer is yes. But how can we achieve that? Of course, we have to use the angles. How can we achieve that? For example, we can do this. Connect these points, BX, CX. Okay, so for these points, I wanna show you that the angle BXC equals to 180 degrees minus angle A. Okay, let's do it. Let us connect these points. Okay, so now what do we have? You can see that we can try to prove that angle BXI, right? BXI equals to angle C, right? So how can we do that? So if you really want to find the answer, You can discover by this, because here this angle equals to this one. What is this angle? Angle CQX equals to 190 degrees minus half of angle C, right? And it equals to angle IBX because IBXQ are consecutive. Okay, and then the angle BIX equals to half of angle A plus half of angle B equals to 90 degrees minus half of angle C, right? So angle BXI equals to 180 degrees minus angle CQX. Not CQX. Angle IBX minus angle BIX equals to angle C. So similarly, we can angle IXC equals to angle B, right? So we can show that angle BXC equals to angle B plus angle C equals to 180 degrees minus angle A. So ABXC are consecutive. Okay, so here it comes to the last step. A, P, Q, and X. Not X. D are consecutive. So let's use a new diagram. How can we show that? You can just see this diagram. We can connect all the sides of this quadrilateral. Is it easy to show any of its interior angles? The answer is not, right? So how can we do that? Don't worry. If you cannot prove the quadrilateral cyclic through its angles, how can you do that? Don't forget that PQ and X are collinear, right? So X lies on PQ and X lies on AD. So we can try to prove XD times XA equals to XQ times XP, right? So that we can make sure that these 4 points AD, QP are consecutive. Okay, so how can we achieve this? Okay, first, you have to notice that for XP times XQ, let me use the purple color. IP times IQ. Let me connect XB and XC here. So do you find that angle XIQ equals to angle XBQ? And angle XPI equals to angle XCI. And fortunately, angle xiq equals to angle xbq equals to angle xcq. So it equals to angle xpi, which shows that the triangle xiq is similar to the angle triangle xpi, which shows that xi squared equals to xp times xq. So since we have xp times xq equals to xi squared, then we have to show that xd times xa equals to xi squared, right? So how can we do that? And I have said there is a model. You can prove by yourself. Actually, since ABXC are consecutive and AX is the angular bisector of angle BAC, then XI equals to XB equals to XC. So we can try to prove that XA times XD equals to XB squared, so that it equals to XI squared, right? So where's the angle? Here it is. Angle XBD here equals to angle XAC equals to angle XAB. So it shows that triangle XBD is similar to a triangle XAB. And it shows that xb squared equals to xi squared equals to xa times xd. So we have shown that xc times xa equals to xp times xq. So D lies on circle A PQ. So that's the end of the proof, and thank you for watching.